Hello, everybody, wherever you may be. My name's Larry. My call sign's Kilo 7 Hotel November. Welcome back to my shack here in Northwest Oregon. This is Ham Radio Live, show number 115. I'd like to ask you to please hit the subscribe button. The subscribe button helps folks find us here on YouTube who'd like to learn about ham radio. It's an amazing hobby. It truly is. It's something that you can do from the comfort of your home and talk to people all over the world with something that you helped create. It's just fantastic. The things you can do in ham radio are wonderful. I hope you can learn some of the stuff here on this channel and on other channels on YouTube that help to broaden your horizons in ham radio. I'm honored you found this show. Thank you so much for watching. Today we're going to talk about general exam questions in the U.S. This is especially for one of our channel viewers named Greg in Maine, who's a really good guy. He's a good friend of the channel, and Greg's going to be taking his general exam test next week, and that's big because right now, as a technician, he only has about 5% of the frequencies you can use in ham radio, but by passing the general exam, which he can do, you can do it, Greg, you'll get 97% of the frequencies available to you. You'll be able to do it. Got confidence in you, buddy. Keep studying, and I hope this show helps you greatly. It was you that I had the whole show in mind for. So I'm going to be heavy on general exam questions, and then maybe we'll see if we can find some time. Maybe we'll make a few calls on the rig and show you folks that might be interested in ham radio what it's like to actually be on the air. Welcome to the show. Glad to be here. Today is the second day of January 2021. We'll start out the questions now. The general exam or license is the second highest license in the United States. It really gives you a lot of power, okay? Meaning that you can work most of the frequencies available to amateurs all over the world. It comes with great responsibility as well. That's why people want you to learn as much as possible so that when you turn your radio on and you get it working and understand how it works with the antenna and everything else, you have some comfort with it. That's the most important part. So we want to just let Greg know in Maine, we have confidence in you. You can do this, okay? Don't worry about it. Hi, Stephen's back from Plymouth, UK. My goodness, Stephen, thank you for coming. I'm always thrilled to see you. And NCT, hey, we got two continents here right now. Look at that. NCT is in Australia. Oh, man. Thanks, guys. Appreciate it. I'm just here tonight. You know, the whole purpose of this show, first of all, it's designed to be listened to. I don't know if you know that. It's supposed to tell a story, each one, in hopefully some visual cues that help, but it's more to help people because I don't want them making the same mistake I did, which was put off getting their ham radio license. We want them to be on the air, and we want to help them. My heart is so much into this. That's why I do this show, and it's why it's not monetized. That's the honest truth. You know, I don't know how much money you can make on YouTube. I don't know, and I really don't care. I mean, I really don't. I've got a home, I'm warm, I've got food, I'm okay. This is my way of giving back. So I really hope this channel can help some folks. Uh-oh, I made a mistake. He's in Wisconsin. Oh, boy. Sorry about that, man. I guess I got to do a little bit of a fast shuffle out of here and say, sorry, buddy. Didn't mean to do that, you know? Welcome to the show. All right, let's take a look at the general exam. By the way, we've got a new general there at NCT. Congratulations. You've got some good frequencies to work now. First question for the general exam in the U.S. Greg, I hope this helps you. I sincerely do. This is why I'm here. Question one. What is one thing that can be done if evaluation shows that a neighbor might receive more than the allowable limit of RF? Now, for people who'd like to be in ham radio, we use certain words here, terms that might be confusing. RF means radio frequency, okay? So whenever you see RF, it's radio frequency. So what might happen, okay? What must you do if maybe your neighbor is getting too much RF exposure from the main lobe of a directional antenna? Thanks for the thumbs up. Appreciate that. It's nice. Okay, we're talking a directional beam, okay? Whether it be a hex beam, an opti beam, a Yagi, a log periodic, some sort of a directional antenna, okay? So we're not talking about verticals or dipoles. You still should check those in terms of their exposure, but This is a directional, so it's forcing all that power in one way, one place. That's where it's going. So if, there might be a little evaluation issue going on and you're pushing too much juice over someone's house, what should you do? The answer is D. Take precautions to ensure that the antenna cannot be pointed in their direction. That would be really hard. Think about that, especially if they're someplace that you like to work and need a whole bunch of countries in. Yep, but that's what the rules say in the FCC. You need to do it. Scott, Colorado, good evening, buddy. Always good to see you, Scotto. Happy New Year. We worked it in together for the Eastern and Central time zone, Scott did. Yep, Scott and I did that on Thursday night. Yeah. Next question for the generals. Which of the following is covered by the National Electrical Code? We just had this question recently, but I wanted to go over it again. The National Electrical Code, when you see this on the test, if you get this question, remember it has to do with electrical safety inside your ham shack, okay? When this test question comes, if it's on your test, when you see electrical, notice there's only one answer that says electrical. Pick that one, okay? Because that's what it means. Electrical safety inside the ham shack. The NEC is basically, they write up rules in terms of how you're supposed to do wiring the correct way so people don't get hurt. So the National Electrical Code is a code of rules that basically set forth how electricians do things to make sure that things don't go burn or blow up or cause a bad problem, okay? So remember, when you see electrical, pick electrical as the answer. Yeah, that's good. Yep, Scott, we're going to get you there. Greg and Scott, we're going to work on this, okay? I know that, Scott, you've got interest, and man, this is my third show today. It really is. And the whole idea for me being here is to help people like you. That's the truth. My heart is so into this. I just don't want you putting it off. Promise me you won't do that. Don't. Because it's not so hard as you think. It's not. I want to give a shout out to my father-in-law here at this example. Kilo November 6, India Ocean Papa. He's in his 80s. He didn't realize he always wanted to be a ham. He thought the test would be way too hard. Scott and Greg, he passed both his technician and general on the first try. You can do it too. Just hang in there, okay? Look at that. Yep. Congratulations on that. That's a big accomplishment. It really is. Next question is for the general exam in the U.S. In what ITU region is operation in the 7.175 to 7.3 megahertz band permitted for a control operator holding an FCC-issued general class license? Now, this can be confusing to people who are learning ham radio or who are trying to license up, okay? Just remember region 2, all right? That's where you can use these frequencies, which are open to you in the U.S., okay? If you're in the U.S. or you're in Hawaii or you're in Alaska, right? United States, that's it. Region 2, we're all considered region 2. So when you get your license, you can use 7.175 to 7.3 megahertz. Just remember, when it says 7.175, that means the limit of your transmit power. The limit of your signal, period, has to be at 7.175, and it can't go over 7.3. Now, in the case of this, it'd be lower sideband, because remember, we're below 10 megahertz. So we'd be on lower sideband. So that means you can't go at 7.175. You need to be at 7.178. Remember, lower sideband, down 3. Okay, very much. Fred, Happy New Year, buddy. Good to see you. Happy New Year to my friend Fred. My goodness, it's great to see you, pal. Thanks for being here tonight. Going over questions on the general exam to help some folks like Scott and Greg get those general exam tickets. We want to get them on the air. That's the whole reason I put this channel together a long time ago. Next question. What's the maximum bandwidth permitted by FCC rules for amateur radio stations transmitting on upper sideband for people who'd like to be hams? When you see USB, okay, it's not the plug-in part to the back of your computer. No. In ham radio, USB means upper sideband. There are two sidebands in ham radio, upper sideband and lower sideband. In the 50s, it became, a thing. Actually, it was only AM until the 50s, and then they realized, hey, we only need a sideband and we can transmit just as well and use less power. Yeah, that's what it was all about. So sidebands became popular. Then there was a big turf war over AM and sideband, and finally we're all converted over to sideband. That's how it is. So what's the maximum bandwidth for FCC rules on amateur radio stations on 60 meters using USB? It is 2.8 kilohertz. Remember, 2.8 kilohertz. On 60 meters, remember, 60 meters is 5 channels only. Only 5 channels on 60, all right? And there is a limit. On 60, the limit is 100 watts for everyone, 100 watts. If you're on 60, that's one of the 5 channels on 60, okay? So please keep that in mind. That's something to be, mindful of. But 2.8 kilohertz is your maximum bandwidth you can use for upper sideband. All right. Now, and that's interesting too, excuse me, because remember, when we're below 10 megahertz, right, we should be on lower sideband. 60 meters is the only exception to that rule. When 60 became available to amateurs, upper sideband became amateur practice. That's how it all came to be. That's the honest truth. Okay, next question on the general exam here in the U.S. Which of the following must a person have before they can be an administering VE, which means volunteer examiner, for a technician class license examination? All right, in layman's terms, what do you have to have? Which license do you have to have if you'd like to be a volunteer test coordinator person for giving tests? Now, there is a person who leads the group, okay? That's the volunteer exam coordinator. That's the leader. Below the volunteer exam coordinator are volunteer examiners. These are people who volunteer their time to come to various places to help administer ham radio tests so people can pass them and get their licenses. It's very important. We need them. So if you have a license, consider being a VE in your local radio club. It is desperately needed today. The answer is given. A, notification to the FCC that you want to give an examination. So that's calling the FCC and saying, I'd like to be a volunteer examiner. That's not the way it works. B, receipt of a CSCE for general class, which essentially means that you've got the general class ticket. C, possession of a properly obtained telegraphy license. It's very, very technically worded there, but no, it's not it. The answer is D. In order for you to give a license exam as a volunteer examiner for a technician, for a future ham radio operator, right? A technician, the first level exam, first level license in the U.S., you must have an FCC general class or higher, and you must have volunteer examiner coordinator accreditation. That means the VEC of your area must train you and prepare you to give tests. That's what it's all about. There are 3 VEs required to be present at your exam to certify you as being licensed. So again, VEs are well needed. If you'd like to and you're a ham that's general class or higher, please contact your local club. Volunteer time. Be a good thing to do for 2021. Which of the following statements is true of the single sideband voice mode? A, only one sideband in the carrier are transmitted, the other sideband is suppressed. No. Remember, in sideband, there's no carrier. There's no carrier at all, okay? B, only one sideband's transmitted. The other sideband and carrier are suppressed. That is the right answer. If you see C and D, just throw them out, okay? C is single sideband is the only voice mode that is authorized in the 20, 15, and 10 meter amateur bands. No. And also D, single sideband is the only voice modes authorized on 160, 75, and 40. No, it simply is only one sideband is transmitted. So 2.8 to 3 kilohertz is transmitted. There's no carrier and there's no other sideband. This is what separates sideband from AM. AM is a center carrier with 2 sidebands. Think of it like a bologna sandwich, right? When we do sideband, get rid of the bologna and the other piece of bread, and you've got your sideband, 2.8 kilohertz, okay? Good way to keep it in mind maybe for your test, okay? Next question for the general exam in the U.S. What does the term 0 beat mean in CW operation? Now, CW is Morse code, okay? A, matching the speed of the transmitting station. That means the speed of the operator who's sending Morse code. B, operating split to avoid interference on frequency. C, sending without error. Or D, matching your transmit frequency to the frequency of a received signal. That's the right answer. Okay, when you 0 beat a CW transmission, you're matching the transmit frequency the same as that of the transmitted station. You're actually just tuning in. That's all you're doing, tuning right on frequency, okay? And there are lots of radios that help you do that. I know a lot of the ASUs do that. ICOMs do as well. Excuse me, as Kenwoods, they all do the same thing. So easy to 0 beat. You'll learn so much more when you have your license and use your radios than you ever learned in the tests because it's practical and it all makes sense. And you go, oh, okay, that's why it was there. Yeah. Next question. Which of the following are objectives of the amateur auxiliary? This is not talked about very much. The amateur auxiliary. A, to conduct efficient and orderly amateur licensing examinations. B, to encourage self-regulation and compliance with the rules by amateur radio operators. C, to coordinate repeaters for efficient and orderly spectrum usage. Or D, to provide emergency and public service communications. The basic objective for the radio amateur auxiliary is B, to encourage self-regulation. Notice that word. That's important. That means the FCC is not stepping in, listening on frequencies and telling people what to do. Amateurs are. Did you know that? Amateurs do this, and they do it voluntarily. It's very cool. When you maybe get a little correction from someone on ham radio, try and take it not personally, okay? Because some people do that as a amateur auxiliary member. So it is to encourage self-regulation and compliance with the rules by radio amateur operators. Give you a good example. If you're in the Western United States, sometime around 8 p.m., all right, there is a sideband signal. It's usually between 7.175 and 7.190, okay? Right in there. And the guy's like 6 to 8 wide. And he loves his bass. And it's like, you know, it's just in professional radio we called that puking. I don't know if you know that. We did when hey everybody, how you doing? Good to see everybody. Got a stacks of wax and a whole bunch of requests for you to play this hour. Stick around. The morning continues. It's called puking. That's what we called it in radio. So these people watch the frequencies to make sure they're being taken care of properly and that people are doing the right thing. So please don't take things personally. They're volunteering their time, okay? Good to know. All right. Hey, Andy, welcome from Great Britain. That's listening. This is great. This is great. Mike 7, X-Ray, Tango, Tango. Welcome from the pond and the beautiful country of Great Britain. Thank you for being here, Andy. What a joy. Thank you, buddy. Next question. What is the standard sideband to generate a JT65 or JT9 signal when using AFSK in amateur band? So we're using digital modes here, right? We're basically using, shift keying, phase shift keying. So USB, always. Remember, if you see this question, you see JT65, JT9, it's upper sideband. That's the standard sideband people use to use those modes, okay? That's all it is. Nothing really technical here. It's really amateur practice. There's no rule that says you have to use lower sideband. It's just that upper sideband that's our practice. That's what we all stick to, and we all agree to do it together because we're all in this together. Okay? Next questions. Which of the following are least reliable for long-distance communication during periods of low solar activity? We have really hit this problem already. In fact, we're getting over it now. Finally getting over it. Sunspots are coming back. Last I saw, there was like 12, which is great because there was a point in the summer, I know it was actually the winter last year, where I remember there was 0. It was insane. So, follow the least reliable for DX or long distance communications during low solar activity, meaning there's not many sunspots, are always the upper bands. Remember, we're talking HF, okay? 15 meters, 10 meters, 12, 15, 12, and 10 are the least reliable. They just don't propagate well when we don't have many sunspots. And the reason why is because there's not enough ionization from the sun to let those higher frequencies bounce off the E and the F regions of the ionosphere. That's really the answer. So that's why they're not as good. That's why it's hard to make calls. And if you ever work 10, if you see 10s working, it's a real good sign to take a look at 6 meters. Yeah, if you see 10-meter propagation working, jump up to 6. Even though it's not HF, you're on VHF there, but you still can work some stuff if you see 10 active. Next question. What usually happens to radio waves with frequencies below the LUF for people who aren't ham operators or who are learning it? LUF is the lowest usable frequency. It means the lowest frequency you can use to make point-to-point contact. Really. And it comes out in propagation forecasts all the time. If you've ever seen QRZ, for example, the homepage shows a forecast. It will say the MUF. It doesn't show the LUF typically, but the MUF, which is the maximum usable frequency, because that's the one we're really interested in. But in this question, lowest usable frequency, what happens to radio waves when they, below that point where it says lowest usable frequency? Hear that? Lowest usable frequency, and they're below it. You can't use it, right? Look at the question. What usually happens to radio waves with frequencies below the lowest usable frequency? A, they're bent back to Earth. Nope. B, they pass through the ionosphere. C, they are completely absorbed by the ionosphere. Or D, they're bent and trapped in the ionosphere to circle the Earth. The answer is C. They're simply absorbed by the ionosphere. They're too low. There's not enough power there. There's not enough frequency there to sparkle up those particles in the ionosphere to make them vibrate and send the signal back to Earth, because that's really how our propagation works. The ionosphere charges up, and those ions, they're up there, and a radio wave hits it, which is basically electric current. They vibrate really quickly. That sends the radio wave back to Earth. Now, if you're really lucky and you're going over salt water, it gets a really nice skip, because guess what's in salt water? Ions, right? So it comes right back up real quick. So you can have multi-skip propagation. It's fantastic. That's why lots of folks can get a hold of Australia on the west coast. Sure, it's 7,000 or 8,000 miles away, but because it's over water most of the way, it's not that hard to do sometimes. So remember, lowest usable frequency, if it's below, there's no contact being made. All right? Aw, NCT. Thank you. That's very kind. Thank you very much. Very kind. Yep, thank you. NCT, study for the extra. You know what? I would, that's a tough one. Do both. Do both. Yeah, Morse code's a really nice skill to have. I tried it for years and I couldn't. I just have a hard time with it. I really did. I spoke with a good friend who's in the medical profession about it. He said, you might be dyslexic at it, because I was getting things backwards and wrong all the time. And I studied hard. Man, Morse code's a nice skill to have. It really is. But the extra, you only get 3% of the frequencies more, and you get the choice of any call sign you want. But then the other thing too is when you're doing that NCT, if you're looking like for a 1x2 or a 2x1 call, like I've got a 1x2, okay, K7HN. There's so much competition for them because there's lots of hams whenever these call signs come available who also put an application in for it as well, and they want it as well. So it's a drawing. It's literally a lottery to get it. So I like the ham. I like the idea of the Morse code thing. That's a great question. Thank you for asking that. All right, next question. What is the purpose of the notch filter found on many HF receivers? The answer is B, is to reduce interference from carriers in the receiver passband. You use a notch when somebody is close by and transmitting and you hear a little bit of their sideband. Say, for example, you're listening to a call coming from another country and all of a sudden you hear this distorted audio coming through. you would press your notch filter and you would turn it away from that frequency. So if you're on upper sideband, you press the notch button and the adjustable dial, you turn it away, down, so lower than that frequency. If you are the other way around on lower sideband and they're just a little bit, right? Just a little bit, just tune away from it. That's what it's there for. Okay? So remember, notch filters on many HF rigs are to reduce interference from carriers, which are other radio stations, from hams, in the receiver passband. All right, next question. Which of the following must be connected to an antenna analyzer when it's being used for SWR measurements? The answer here is antenna and feed line. Antenna and feed line, okay? An antenna analyzer, all it really does, it tells you what the impedance is of your antenna and your feed line. It's really simple. There's lots of different kinds. And I don't have one over another that I recommend. I've used a few. My favorite one, I purchased this, 2 years ago or so, is the Zoom 35. Works really great. And the only thing you got to connect into it is an SO239. That's it. So coax connection right there, just like it's going to your radio and up your antenna. It'll give you the measurement of your SWR. It'll also do a sweep of the frequency bands. It'll do a ton of stuff. Antenna analyzers are really cool. Get to know them. And once you do this and you start building your own antennas, which you'll probably do, I said I never would, but I did. You'll have a ball. It's fun. All right, we got to hurry on. Sorry, guys, going too short. Don't want to, but don't. I always try and do this in ways that people understand it without getting technical. This whole class, this whole show, all of them are to be in layman's terms or to try and use examples that people can understand without being too technical. I want a kid to be able to understand this. That'd be the greatest joy ever, to help a kid get on the air. I would always remember that. Okay, and this one keeps coming up. Why is it doing this? I have no idea. I've got like 4 of these, it looks like, and no wonder. Okay, oddly strange. Okay, how close to the lower edge of the 40-meter general class phone segment should your displayed carrier frequency be when using 3 kilohertz wide lower side band? We talked about this a moment ago. It would be 7.178. 7.178 is the frequency. That's 3 kilohertz above the edge of the segment. Excuse me. Remember, you're on lower sideband. There's a brother to this question on the test as well. That reads, how close to the upper edge of the 20-meter general class phone segment should your displayed carrier be when using 3 kilohertz wide upper sideband? That answer is my mind went blank, 14.347. Okay, 3 kilohertz above the edge of the segment. In this case, remember, we're on lower sideband. So at least 3 kilohertz above the edge of the segment. Okay, because you're on lower sideband, your signal's here and goes down 3 kilohertz. Okay, down 3 kilohertz puts you at 7.175, which is the limit of the general class for 40 meters. That's why. So 3 kilohertz above. All right. Next questions here. For everyone that's looking to get that general ticket, what is one disadvantage of using a shortened mobile antenna as opposed to a full-size antenna? So this is for those handheld radios, right? Like the Balfangs, the Yaesus, let's see, ICOM's got tons of them. Kenwood's got them. Short antennas, A, are more likely to cause distortion of transmitted signals. No. B, short antennas can only receive circularly polarized signals. Remember, there are 2 types of polarization, vertical and horizontal. There is no circularly polarized signal. Okay. C, operating bandwidth may be very limited, or D, harmonic radiation may increase. The answer is C. Operating bandwidth may be very limited. The reason why this happens is because on a shortened mobile antenna, they're really they have a high Q. When you have a high Q, you have a very, very narrow tuned area. Very narrow. 3 to 4 kilohertz sometimes. It can be very small. So when you have a shortened mobile antenna, that That's your problem. It's called high Q. High Q means that it's going to be very narrow. It's going to give you a smaller bandwidth to work with. Doesn't mean the rest of the band is not open to you. It doesn't mean that at all. Remember, it says operating bandwidth. That means transmit and receive. So the transmit part is going to be very, very limited, okay? We've got a few more questions here. All right. For generals, especially for our friends Scott and Greg, what is one reason to use an impedance matching transformer? This is a technical term for what we call an antenna tuner. It is, same thing. All right. A, to minimize transmitter output power. B, to maximize the transfer of power. C, to reduce power supply ripple. Or D, to minimize radiation resistance. The answer is B. The reason you use an impedance matching transformer is to get as much transmit power to your antenna as possible. You're making the radio happy. That's all you're doing. The antenna is already going to be what it is. An antenna is an antenna, okay? Once you tune it and trim it so it's resonant, you can get the most power from your radio to it, whether it be 5 watts or 1500 watts. But if you're using an antenna tuner or an impedance matching transformer, you're just simply trying to make your radio happy to make the most amount of power go to your antenna. That's all. Okay, what percentage of power loss would result from a transmission line loss of 1 decibel? The answer is C, believe it or not, 20.5%. Yep, that's 1 dB of loss in transmission line. That's why I always say, first thing to buy for your ham shack is good feed line or transmission line. Good feed line. That's going to save you dividends huge, okay? Let's go 3 more, and I've got a practical examples. I want to show you a couple of practical examples, okay? What's the capacitance of a 20 microfarad capacitor connected in series with a 50 microfarad capacitor? Now, before you add 50 and 20, don't, okay? Don't do it. It's not 70 microfarads. The answer is 14.3 microfarads. That's the answer to this question. Okay, so when you see this one come up, immediately think touchdown. That's what I did. People are going to laugh, but that's how I remembered it. I'm just sharing with you the way I did it. Okay, next question. It's the same one. And I'm sorry, I don't know why it's doing this. It's like duplicating like a bunch of questions here. So I'm going to go to the last 2 that I have in my list here, okay? Which of the following is an advantage of using a gamma match for impedance matching of a Yagi antenna to 50 ohm feed line, okay? So you're matching a Yagi, which is a directional beam, to a 50 ohm coax feed line because it's not going to be 50 ohms, okay? What it does is it makes sure that you don't have to have the elements insulated from the boom. Yeah, it's basically a way that you can kind of keep everything right the way it is without taking it off the boom connect-wise. Meaning you got a big old tower there, right? And you got a rotator, and you've got a a little not a little, it'd be quite large actually, rod coming up from your rotator which turns your Yagi, okay? When you're using a gamma match for it, you don't have to insulate it from the boom at all. It doesn't need to be insulated from that pole. It doesn't have to be because the gamma match takes care of everything to keep it at 50 ohms of impedance. That's the answer. That's the reason why, okay? Next question for the general. What is the advantage of vertical stacking of horizontally polarized Yagi antennas? So this would be one Yagi and another one below it. Yeah. You could do it. You might ask, well, how is that even possible, right? You've got an antenna and you got an antenna above it and they both spin. It's possible because hams are that resourceful. It's true. Okay, the answer is it narrows the main lobe in elevation. This is what helps to bring the signal down, okay? When you stack Yagis, what they do is it helps to bring the elevation angle of your takeoff down. It also helps to really increase your gain. So gain is increased plus your elevation angle. There's one I wanted to find that was interesting because it's wrong, but I wanted to share it with you, the right answer. Here it is. What's the approximate length of a half-wave dipole antenna cut for 14.250? Okay, the correct answer is really 33 feet. That's really the correct answer here. It's simple. And this is the formula to take in with you for your test. If you see anything that talks about cuts for antennas. Okay, whether it be dipoles or verticals. Okay, now this is again U.S. We're not talking about Europe or Australia or Asia or any other country, Canada, anything. We're not there. We're talking about U.S. because this is a U.S. test. All right. So what you do, keep this in mind because this is going to help you big time. Remember the number 468. Okay, 468. It's pretty simple. They're 2 digits apart. 468. Whatever that number, and they'll let you bring a calculator with you, and they'll let you bring pencils in with you. So you're okay there. Sorry, my gain got a little hot. Not sure why, but we turned it down. Remember 468. Take that number and divide it by whatever frequency they're talking about here. That's the correct cut for your antenna. That's exactly what it is. So in this case, they say 14.250, right? The actual answer is 32.84 feet. Now, if you're cutting an antenna, that's a lot closer to 33 than 32. I know I'm splitting hairs, but if you're building an antenna, 8 inches is a big difference. Actually, it's about 8 inches. That's a big difference when you're building an antenna. It really is. Because I'm talking, when I trimmed the DX Commander, I was cutting small, like half-inch pieces at a time just to get it down. So the answer says 32 feet, and that's correct. But technically, it's 32.8. So just bring your calculator. Remember that formula, 468 divided by frequency for any one of these questions they give you, and you'll get it right every single time. Okay, let me look for one more question because there's a couple of visuals I want to show you with it, okay? That's not the one. Let me find it here. It's a, here it is. Sorry. Let me pull this one up. It's going to be hard to see. Okay, this is tiny, okay? This says, and I know it's small, which symbol in figure G71 represents an NPN junction transistor? All right, there's 2 transistors here. The one in the center is a FET transistor, okay? That's a field effect transmitter. The one on the right, that's to the right of it, number 2, which is right over there on the far right side center, that is an NPN transistor, okay? Notice the difference. There's no arrow inside, no triangle pointing at the T, okay? There's the gate, shows where it's pointing out, but that's it, okay? Let me show you what these do because it's important, okay? In-gate transistors work this way. All right. You have your incoming power, okay? There's your N-type emitter, which is the reason why it's called an N-type transistor, okay? It's got an emitter and a collector. In the middle, there is a P-type base, okay? Notice what the electrons do here, okay? You see the power sources on your left. There's 2 of them, okay? And there's a reason there's 2 of them, because this amplifies current, okay? This amplifies current. These type of transistors, my friends, are what got us solid-state transmitter antennas. Transmitters. Amplifiers, radios, without tubes, okay? The world changed greatly once NPN transistors were improved to the point they could be used in amateur radio because they could increase the current that was going through the system. They can be used as amplifiers. Same with field effect transistors. They do the same thing. Field effect are a little different. FETs are a little more finicky, but they're also very good and used in many amplifiers. Now, let me show you real quick the inside of a tube. You'll see the similarity, okay? Here's a regular tube, okay? I know it looks like the 50s because it is from the 50s, okay? I'm going to put the transistor next to it so you can see both of them. All right. Notice the electron flow on the right. You see how it goes from the bottom to the top? All right. The bottom of the tube is the emitter, okay? The bottom of the tube is the emitter, okay? That's where the power comes in. Now, because tubes are vacuum sealed, there's no oxygen in them, okay? Electrons flow like crazy to the top, which is the only metal plate, the only metal piece in the tube besides the electrode, okay? The only part here is the top, which is the plate. That's the collector. So these electrons flow at the speed of light up to that plate, and they amplify power. That's what they do. In a NPN transistor or a field effect transistor, they do the exact same thing, but they don't need to have the emitter doesn't need to have the filament. You don't need to have the worry about the glass, the grid, all those things that can make it unreliable. Okay, this makes it simple and smaller and easier to put into a ham radio or an amplifier. Okay, they do the same thing. This is why tubes have been replaced, but tubes are still available in amplifiers in many places, and they work brilliantly. I love tube amps. I still do. To this day, tube amps just bring joy to my heart. I love the color of it. I love the smell. They have a smell to them, and they're just, you can hear a little bit the difference in signals, I think, sometimes. Yeah. So I really wanted to show you that because that's important when you get to transistors. Transistors help to increase current, just like tubes did, or valves as they're called in Europe. A tube is called a valve there, okay? Because basically it takes power and you open up the valve and it shoots those electrons up to make more power. The grid that goes between it. Let me show you real quick something real fast. This broke, by the way, so hold on. Okay, since we're talking about transistors and tubes, this is a 500Z, okay? Here is the place where everything comes in. Here's where your power starts, okay? Now inside here is your element, okay? That's what heats up, makes it glow orange. The electrons flow up at the speed of light in here. They need to be controlled. So this gray, see that? This beautiful gray slotted piece in the center, that's called a grid. That's what helps control how many electrons and how fast they go up to the top plate. That's why they have them. So on tubes, that's why we adjust our plate voltage, our grid. Here's why. Because they have to be to keep them stable. This poor guy broke. I feel terrible because I love this tube. The 500Z is like my favorite. I love the 500Z. Yeah. So when I was at MFJ, I saw this. It was on a storage shed shelf. It was a bad tube. And I said, oh, can I have that? I was thrilled. And then I bumped the table and it, went down. But it's still very usable to be shown here. If you take a close look, the cathode, you can kind of see everything just a little bit. Let's see if I can get you a close view. The cathode is inside there, okay? And basically it just starts at the bottom, works its way up quickly, ends at the top here, and it makes more power. That's what it does. Let me get into your comments real quick. Tom's here. Oh my gosh, from Bahrain. Tom, thank you for being here. Hobby, the internet, and YouTube. Thank you, my friend. Thank you so much. Yeah. You know what? What you say here is good. I want to hold on. Let me put this back up. For people who are studying, look what he says. I agree. I encourage everyone to study, to take more than one exam. Anyone can do it. Yes. Don't be so scared of this test or worried about this test that you're worried about taking it. First of all, they don't put a ton of math purposely on it because they do want people to be in ham radio. They do. That's important, okay? The second thing is if you study, and even if you're not smart at science, okay, but you have an interest in radio, you'll pass this test. You will, because you have the desire to. If you have the desire to take this test, you'll pass it. Don't be afraid to go up one more and say, yeah, I'll try it. Sure, absolutely. You may be surprised. You walk out of there with a general ticket, and now you got 97% of the frequencies, and you're saying, oh my gosh, what radio antenna do I buy? Remember, antenna first. Antenna first. Let me put this before I break it again. Okay, so that's it. That's the show here with that. The whole goal here is to really help people get licensed and to encourage you not to take this so seriously that you're worried you're not going to pass it. If you don't pass it, you don't pass it. Life isn't over, and don't ever think about stopping. Okay? I felt awful the day I passed my exams because the guy sitting next to me was trying to get this technician ticket and he missed it by one question. And I felt so bad. I really did. I felt bad for him. I remember that feeling was awful. And I just kept taking my license exams because I'd studied really, really hard. It meant the world to me. I was already 19 years late. I was. That's why I do this channel and don't monetize it, because I don't want if I know I could have helped at least one person not make the same mistake I did, then I'll feel really good inside. So that's why this show is being produced tonight for people like Greg and Scott. You guys can pass this test. There's a couple of places out there. I think it's called hamstudy.org is one of them. Ham Radio Test Online is another one you can take. They both cost money, but I think they're well worth it because they have practical lessons that go with it. There are also some really good people here on YouTube that teach each level of exam. Yeah, so you can find that as well. Find what works for you. Okay. In the case of my father-in-law, I kept telling him, no, use this software. And he was like, I don't like that. I want to use this software. Whichever software works for you, use it. Use it. But once you get your license, the number one thing people do is immediately think right away, radio. What radio am I going to get? Radio. As an exam for you to probably give you the best advice, think your antenna before you think anything else. Because you can have the best radio ever made in the planet and have a bad antenna and it won't mean anything because you're going to be frustrated using it and not making any calls. So work from the top down. Research your antennas. Go to your feed line. I like LMR 400, but I don't use it because it's too expensive. I use a cheap knockoff of it, but it's still LMR 400 quality. But use a good antenna, then use quality feed line, then go to your radio. I know that sounds boring, and I know that's probably what you don't want to hear. I know that. But I've done radio for many decades, and I'm telling you, nothing is great unless the antenna works really well. That's where you start. Start at the top. Antenna, feed line, radio, and you're set. You'll be set, and you'll be so thrilled because that radio's going to work great. It will. Let's get back to your comments. Sorry about that. Now, thanks for the tube. Man, when I got that NCT, I was bummed when I broke it. I was like, no. Felt awful. Anyway, tonight should make me want to get my extra class license. And you know what? That's a nice comment too. Thank you very much, Smokey. You can get your extra. Absolutely, bud. Absolutely. I've done some extra shows here. I'm usually on Fridays, but the holidays, both Christmas and New Year are on Fridays this year. And no, we'll go back to extra Fridays next Friday. So we'll do an extra class again, and we'll keep doing them. You can do the extra. The thing to keep in mind with the extra is it's 50 questions instead of 35, but you can miss 13, okay? Little more margin for error there. And again, like the other two tests, they aren't going to be heavy on math. You won't get more than 3 math questions, so don't worry about the math. The last piece on the extra I can tell you, and the same with generals, by the way, you will find questions that were on the technician on your general exam and on your extra exam. They will be there, okay? They want to make sure to drill certain points home, especially FCC rules. Very important, you know them, okay? That's important, okay? Offset or dipole, yep, works wonders. G5RV, great antenna. I've got one. I love it. I've worked a long ways with it. Wire antennas are my favorite. They just are. I mean, there's something special about putting a wire up and letting her go. It's, you created it, right? I mean, you helped create it. If you buy a commercial product, you built it by setting it up. You did that. And it works because of your hard work. There's something special about that, I think. Radio is a very cool hobby, and I hope I've helped you tonight. I really do. Let's see if we can get any calls just to say hi to somebody, just for a quick moment. Okay? Let's take a look. We're on 40. We're on 14 meters. Let me check the antenna real quick. I am going to be moving over shortly to the K3, just so people know. I want to, for two reasons. I want to get more familiar with it. That's number one. And number two, I want to be able to just, kind of get using a different radio as well, just because it's nice to give some variety here while we can. So the K3 is going to be coming. One thing I will show you on the 7300, it's pretty simple. It's a little simple thing. You see how there's no waterfall? Maybe you can see better if I turn this down. Just a second. Let me turn this off. Okay. Notice how there really is no waterfall there, right? See the waterfall is kind of just all black. Okay. You see a strong signal here. That's going to be most likely shortwave. But if you hit the reference button, it lets you tune it by the VFO. Now watch what happens to the waterfall. See the intensity pick up at the top? Now you start getting a waterfall. That's how you adjust it. I like to keep mine just a little, almost like little raindrops, almost like little snowflakes, because I can see the intensity here in green, which I like, but I don't want it looking like this, because then I really can't see anything if you put too much in it. So back it off to a point where you're real comfortable and you can see just like a little bit of rain and you still see that intensity up top. It's a nice radio. It's nice to use it, because the screen's right there and it's so easy to use, just so easy to use. This is a wonderful radio. It really is. A lot to it. Lots of questions lately about it too, compared to the FTDX10. So quite a few. Let's see what we can do if there's anybody out there. Okay, give me 1 second. Hang on. Okay, just changed antennas. So we're now on the high gain AV680. Just narrowing down the passband a little bit. Okay. Now this is going to be something for new US generals. It's going to be hard. Let me show you real quick. In Europe, in the UK, you can go 7.1 to 7.2. Now in the US, we have to stop at 7.125. This is where it can get kind of a little bit frustrating for US folks. Got a CW guy there. Another one. It's supposed to be contest weekend. Raw digital. Okay, so there's got to be some CW contests going on today. All right, so let's go over to 80 and see real quick what's happening there. Listen to all that. Wow. That's all digital. Hey, Steve. Steve from Liverpool's here. Hi, Steve. Welcome to the show. Nice to have you, buddy. Thanks for being here. Just checking the 7300 here from the northwest of Oregon. Taking a listen and seeing what's here. We're on 80 meters here. Now, I have another love in radio I got to share with you real quick. Hold on a sec. Let's just zoom up here. There's a few signals up here. Nope. Okay.
Well, good evening. Okay, you're 5 and 5, just over my noise level. Any station anywhere, call now.
Kilo 7 Hotel November.
Ending in Papa.
Sounds like this might be a net.
Station ending in Papa, come again. Okay. One more call. Any station anywhere for the BC Public Service Net.
There we go. Okay, for the British Columbia Public Service Net. There we go. Now we know. Okay, my favorite is top band. I love 160, I do. And waiting for the antenna to arrive still. Parts are hard to come by right now for everybody. So it's a slow time. Get the reference up here a little bit. There we go. Nope. So for people who are new to ham radio, this is right above the AM broadcast band in your vehicle or in your home. Old timers call this top band because it's the highest frequency available to ham radio operators. This is the highest meter band, not highest frequency, sorry. Pretty slow. All right, pretty slow. So it's a slow night tonight, at least from here. We're buying the Wellbrook loop, by the way. We're buying the ALA 1500, I think it is, and looking forward to getting another Wellbrook. Had them in the past, and I love them. It's truly the gold standard of radio antennas for, ham radios or whatever. It's the ALA 1500 Lima November. So yeah, the ALA 1530 Lima November. Coming from Great Britain, so I'm going to have a couple of UK antennas. I'll have Callum's DX Commander for my transmit and then the Wellbrook for receive. I love to use receive antennas to hear on because it brings the noise floor down. You can hear better with them. Shortwave DXers have used them for decades, and I think for ham radio operators, if you've got a radio like, I know the 5000 will do it. The 7300 does not have multiple antenna inputs, so you can't put a receive-only antenna in it, but a radio like this, the FTDX 101s, the 7610s, the Elecrafts, they all, and the let me see, the Kenwoods. I know that I think the 590 SG does, the 990, the 890. By the way, the other day, I remember we had some, I forget who it was. Yeah, I love the 890. 890S. Love this. Just love this. It's such a beautiful radio. And I talked earlier about the meter on it, right? Look how real this meter looks. It looks like it's a real meter, but it's all digital. Isn't that amazing? It looks beautiful. And all you do is you just tap on it and it changes to a black meter with red lettering and a red needle. It's just cool. Or a white needle, sorry. But it's fantastic. It's a beautiful, beautiful radio. It really is. My wife. I'll get to her. I will. So yeah, the 890 is a very, very special radio in my heart too. It really is. I think it's beautiful. Also very good sounding, the 890S. There it is. I have one for the 990 and for the 890S. Kenwood makes beautiful radios. Very good quality as well. Very good quality. So, all right. Let me learn here. See what we got here. Live stream. And Stephen, thanks for being here. I appreciate that. Love to learn more about receive-only antennas. My IC765 has a connection for one. We will. Once we get the Wellbrook my friend, I'll show you how it goes in. I'll show you how we all connect it and how it works. Your radio will automatically use the RX antenna to receive on so it doesn't blow it up, because you don't want to put even a single watt into a receive-only antenna. If you do, you'll destroy it, okay? But if you use it properly and have it as an RX-only antenna, you can use that for receive. You can rotate it even if you want to really tune in those stations, and then use your regular antenna to transmit on. You're going to have the best of that RX world. You'll love it, okay? So I will, hold on a second here. Let me do this. There you go. Must be important. I better go. Thanks for watching Ham Radio Live, everybody. Greg, Scott, I hope the show helped you guys. God bless you. Have a wonderful evening. And we'll be back hopefully tomorrow. 73 to everybody. Yes, the FTDX 3000, one of the very best radios I've ever used. It does have a dedicated RX. Thanks for adding that, Tom. God bless you. From the northwest of Oregon, this is Larry. My call sign is Kilo 7 Hotel November. Good night, everybody.